This is Shiv Ram presenting AdaNorm paper. So in deep learning community, Adam optimizer is very common and it computes first moment and second moments by utilizing the exponential moving average of gradient and squared gradient respectively, which is used for the parameter update. However, Adam faces the problem with respect to the quality of gradients that it get for different batches where the norm of the gradient might not be consistent. So we propose to correct this problem in terms of the gradient norm correction. So basically we perform this gradient norm correction by utilizing the historical norm of the previous gradients that network observes for different iterations by computing exponential moving average of the norms of the past gradients, and then this gradient with the corrected norm is used to compute the first moment, and based on that parameters are updated. And this is very useful for the scenarios like S1 and S2 where we require the larger updates, and then we find that in these regions the ST is going to be larger, and basically it is leading to the larger updates in S1 and S2 regions. We also observe the mean gradient norm for different networks like VG16 and ResNet18 utilizing on different these datasets like CIFAR10, CIFAR100 and TinyImageNet, and we observe that the norm of the gradient is in all the cases it is higher as compared to the norm of the gradient when we don't use the gradient norm correction. For the experiments, we utilized three CNN models with VG16, ResNet18, and ResNet50 on popular datasets like CIFAR10, CIFAR100, and TinyImageNet datasets. We also use our optimizer with four state-of-the-art optimizers like Adam, diffGrad, Radam, and AdaBelief, and we propose Adam norm, diffGrad norm, Radam norm, and AdaBelief norm, but it could be utilized with any of the existing adaptive optimizer. Experiments are done in PyTorch framework. Training is done for 100 epochs with a batch size of 64. Learning rate is set to 0.001 and dropped by a factor of 10 after 80 epochs of training. So this is the classification results on using these Adam, diffGrad, Radam, and AdaBelief optimizer without and with the proposed gradient norm correction on different datasets CIFAR10, CIFAR100, and TinyImageNet with three different networks VG16, ResNet18, ResNet50. We find the consistent improvement in almost all of the cases, and with the higher improvement on these TinyImageNet datasets it is observed. We also find that this improvement is consistent across different epochs of the training, and the same thing is also observed from the loss, which is consistently down for all the epochs of the training. We also observed what is the effect of the hyperparameter that is used for exponential moving average of the proposed history based gradient norm computation. So we find that the value of this gamma like 0.99 is better suitable as compared to other values, but on some data sets on some models like ResNet50 the hyperparameter value as 0.9 is better suitable. We also observe that when we use the proposed concept with only first moment, then it is going to be beneficial. With respect to the learning rate, we find that when learning rate is generally smaller, then our method performs in a better way. And with respect to the batch size, so it is also observed that for Adam, it is going to be good when batch size is higher, like 128. However, in our cases, generally we are getting better performance when batch size is 64. So these are the references, and now the code for this particular paper has been released on this GitHub page, and you are welcome to use this code if you are interested in this particular research. Thank you very much.